Well, in previous screencasts, we've talked about how to work with logarithms, and you may have been asking yourself, why do we even need logarithms? And it turns out that lots of natural processes vary over a really large or really small range. And so logarithms help reduce that range to something we can work with more easily. And examples include earthquake intensity. Have you heard of the Richter scale? That's a log scale. Light intensity, sound intensity like decibels. Those are log scales, and pH of solutions, which measures the acidity of a solution. So one of the most famous examples of using log scales is with the Richter scale. And the formula for that says that an earthquake with an intensity of I has a Richter scale magnitude of the log of I divided by I sub 0. And I sub 0 is a measure of the intensity of a zero-level earthquake. In other words, no activity. Okay, so we're going to find the Richter scale of the 2008 Panama, Costa Rica earthquake that has an intensity of I equals 1,584,893 times a zero-level earthquake. All right, so M is going to equal the log of 1,584,893 I sub 0 over I sub 0. Notice this is a common log, so the base is 10. The I sub 0's cancel, and I'm going to bring up my calculator here. I'm going to hit my common log button. I'm going to put 1,584,893, and we get 6.2. So that Panama, Costa Rica earthquake had a magnitude of 6.2 on the Richter scale. Now let's try an example going in the other direction. What happens if we know the Richter scale and we'd like to get the intensity? Okay, so 5.4 is going to equal the log, remember, of I over I sub 0. And since this is a common log, it has a base of 10. So converting to exponential form, 10 raised to the 5.4 is I over I sub 0. We want to solve for I. So I'm going to go ahead and go 10 raised to the 5.4 power. And I get 251,189. 251,189 times I sub 0 is equal to I. So in other words, the 2008 Los Angeles earthquake was 251,189 times more powerful than a zero-level earthquake. All right, now let's compare two different earthquakes, the 1960 Chile earthquake with the 1989 San Francisco earthquake. All right, so based on that previous example, we can go ahead and do a shortcut, and we can say that 10 raised to the 9.5 times I sub 0 is equal to the intensity of the Chile earthquake, and 10 raised to the 7.1 times I sub 0 is equal to the intensity of the San Francisco earthquake. All right, so that means that if I'm going to compare Chile to San Francisco, I'll go ahead and divide them. So 10 to the 9.5 times I sub 0 divided by 10 to the 7.1 I sub 0 will equal the intensity of the Chile earthquake over the San Francisco earthquake. And I get 10 to the 2.4. And let's work that out. 10 raised to the 2.4 is 251. Okay, so the Chile earthquake is about 251 times more powerful than the San Francisco earthquake, even though their Richter scales were only 2.4 difference. We also use logarithms when we're talking about the pH of a solution, and that's a measure of the hydronium ion concentration, the positive hydrogen. atoms in moles per liter. And the pH is the negative log of the H plus number. Solutions with a pH less than 7 are acids, and a pH greater than 7 are alkaline or bases. So what's the pH of orange juice if it has an H plus number of 2.8 times 10 to the negative 4 moles per liter? Okay, well, pH is the negative log of 2.8 times 10 to the negative 4. And let's get our calculator up here. And I'm going to go negative common log 2.8. And to do scientific notation, we're going to get this EE right here. It's going to go second E. Whoop, I got a comma there, didn't I? Let's delete that. Second E, negative 4. That's the shortcut way of doing times 10 to the negative 4. Enter, and we get 3.6. Okay, so let me move that over here. So, to the nearest tenth, that has a pH of 3.6, which means it's acidic. Remember that 7 is neutral, below 7 is acid, above 7 is base. Well, let's figure out what the pH is of milk. So the pH is going to be the negative log of 3.97 times 10 to the negative 7. And we'll clear that out. Okay, negative log 3.97 e to the negative 7, 6.4. And let's see. So that's pretty close to being neutral, isn't it? Because remember that 7 is neither acid nor base. And finally, let's check out the pH of some rainwater. So pH is equal to the negative log of 6.31 times, well, I'm just going to erase that. That's a mess. 6.31 times 10 to the negative 5, negative log 6.31 e negative 5, and we get 4.2. So it's slightly acidic, I guess. Okay, acid rain. And our last example, what happens if we know the pH? We like to get the hydronium ion concentration. We like to get the H plus number. Okay, well, 7.3 is the negative log of the hydronium ion concentration. And that means negative 7.3 is the positive log of H plus. This is a base 10, so converting to exponential form, 10 to the negative 7.3 is equal to H plus. And when I work that out, I'm going to get 10 raised to the negative 7.3. Whoop. Let me insert that negative in there. There we go. And what we get is 5.012 times 10 to the negative 8 mole per liter of hydronium ions.